Hi, it's Greg from Scholar Farms, and this is part 2 of a video series that I did of a series of interviews with the University of California folks. And so I got a lot of different perspectives about drone technology, plants in the state of California, how these different technologies can be applied to monitoring ecosystems, both managed and natural ecosystems. And so I thought you'd be interested in listening in. If you haven't listened to part 1 already, you can check it out, but this is part 2, and with that, we'll cut to the interviews.
Hello, my name is Sean Hogan. I work for the University of California Division of Agriculture and Natural Resources, and within that division, the Informatics and GIS statewide program. So the Division of Agriculture and Natural Resources is the branch of the UC system that is engaged with the public through cooperative extension. A lot of the things that I do with drones are in support of farm advisors and natural resource advisors throughout the state that are interested in bringing practical geospatial technology to the average person that's out doing any kind of land management.
And we're typically at Scholar Farms, our audience is thinking about plant data. And so tell me a little bit about the setup that you have behind you and how it relates to plant mapping in the state of California.
So what we're looking at right here is a Matrice 100 drone that was built by DJI, the primary, or I'd say the main consumer market drone manufacturer in the world. This has a Zenmuse XT camera that's partnered with FLIR, which is a thermal imaging camera. Behind that, I have a multispectral camera that, and I could tilt that up so you can see that a little better. A multispectral camera that collects not just red, green, and blue imagery, but also near infrared and the part of the electromagnetic spectrum right between near infrared and red. The value of that is that near infrared is one of the most highly contrasting portions of the spectrum related to plant health and vigor, and the red edge between the near infrared and the red, that's sensitive to water stress.
And so tell me about how do you sync those data together? A lot of people are interested in thermal data, multispectral data, RGB data. What are some of the best ways to think about how you merge those data layers together?
So there's a lot that goes into this, and it's not trivial at all. And in fact, you are limited by the technology to a certain degree. What you need to do is you need to geo-register your imagery so they're exactly lined up. And then you can use mathematical formulas to see what the relationship is between, say, a plant that has a near-infrared reflectance of Y and another plant that has the same exact near-infrared reflectance of whatever Y, and then compare that to two different contrasting thermal qualities. What that tells you is if the plant that is the same exact color has a higher or lower temperature, at least it indicates that one has more evapotranspiration going on, which tells you how much biomass your plant is taking up.
So in California, we're really interested in water use and drought. What do you think the future of drone technology in measuring and monitoring California plants is? Like, what are the big opportunities?
Well, I think what's going to happen in the future is this technology it's going to become easier and more practical. Prices are going to go down. The processing power of the applications that you use after you collect the imagery are going to speed up and become more affordable. And then after that, you're going to be able to integrate this type of imagery, the thermal imagery and the multispectral imagery, in ways that it's much easier than it is done now.
So all about the analytics, basically.
Yep, it's the analytics. I always say that people think of the drone technology, and it's really neat what you can get with the cameras and what you can do with the multispectral imagers, but really the work starts when you have the imagery and how are you going to create a usable product out of that.
Hi, I'm Jacob Flanagan. I'm the drone technician and data analyst for IGIS. I've been using drones for several years. I got into it initially because I worked with LiDAR. And we kind of transitioned from the larger aircraft to something a little more smaller, and especially with the new LiDAR technology, it's allowed us to essentially put these sensors on drones. Yeah, LiDAR is pretty great in the sense that it can actually penetrate canopy, and it will reach down to and get those ground points that are below canopy. Mostly what you get from LiDAR is just structural information. So that is something you can extract from imagery as well using something like photogrammetry. But laser's more direct, so think of like a rangefinder. So you're measuring those distances in much greater density than just a rangefinder.
So I can do things like wood volume or carbon budgets, or tell me kind of what are people actually estimating?
Absolutely, you get these great, very detailed structural, volumetric information from these LiDAR point clouds.
My name is Jeremy James. I'm the director of the Sierra Foothill Research and Extension Center.
And at the Sierra Foothills, there's a lot of work that goes on, particularly with thinking about grazing and grazing management and the interaction with natural ecosystems. Can you tell me a little bit more about what you guys do and what your interests are in that?
Sure. So over 20 million acres of rangelands grazed in California. And so we're really interested in supporting research and extension around the interface between how you can maintain these livestock production systems across these vast landscapes, and also support the sort of mini ecosystem services that are associated with these landscapes, like carbon sequestration, biodiversity, wildlife habitat, and water quality.
So we know that grazing is super important to California families, been around for hundreds of years, but at the same time we have to manage the natural ecosystems, got to create a balance. Our community is really interested in drone technology and how drones can contribute to grazing. What are your thoughts in terms of drones as tools for grazing management?
Yeah, really good question. So I think any tool that allows managers or producers to sort of monitor and manage their landscapes at large spatial scales, cheaply and quickly, could be really, really useful. So the potential to use drone technology to cover thousands and thousands of acres at low cost and rapid speed, I think, is of huge interest.
Yeah, so we've talked a lot about multispectral cameras and vegetation mapping, but just using a Mavic or Phantom 4 Pro or something like that, you think low-cost drones can also help farmers out and not have to dive into tens of thousands of dollars of drones?
I think so. I mean, there's a different sort of spectrum of questions, and different ranches are interested in different types of monitoring tools and variables. But I think, it can run the gamut from, sort of what does my pasture look like? What does the animal distribution look like? Where are my animals? To things like how much forage do I have left? How green is the forage? What's the nutritional quality of this forage?
Sweet. And so if folks want to learn more about Sierra Foothills, where can they do that?
Sure. So we have a website. If you just type in UCSFREC in any search engine, it'll pop up, and there's plenty of information about the research and extension programs we have there.
Hi, I'm Andy Lyons. I'm a program coordinator for the Informatics and GIS statewide program, which is a program within the UC Division of Ag and Natural Resources. Yeah, so our unit, we started using drones about 2 years ago, and we're excited about the new technology. We do a lot of flights and missions for researchers within the UC system, and we also do a lot of workshops training researchers as well as landowners and growers and land stewards to use these technology to collect data, to make maps of their areas, to plan projects, to monitor projects, to do research about plants and all kinds of stuff. Yes, so Drone Camp is coming up. We do one big multi-day drone training per year. We call it Drone Camp. This year we're doing it at UC San Diego. It'll be June 18th to the 21st. It's a 3-day training. We cover everything from mission planning to learning a little bit about the different technology and the different aircraft, the different platforms. We talk about the regulations. We spend about a half a day actually flying the drones, so giving people practice on both manual flight as well as using flight management software to do data acquisition. And then we have another full day spent just on data processing, where you stitch the images that come off the aircraft, and then doing some analysis, because what you get off the aircraft are nice orthomosaics and different 3D products, but then there's often another step to answer the questions that somebody's interested in.
And who are the folks that typically take Drone Camp? Like, who are your audience?
Drone Camp is totally open to the public. I would say it's about half people in academic settings. So a few faculty, a lot of grad students, some undergrads. And then the other half would be everyone from this year. We have some people coming from state agencies, the National Park Service, or sorry, the State Park Service, Land Trust, and some people who work with facilities. So we focus on drone mapping. We're not doing videography or robotics, but within that, there's a lot of applications for the data that these things can collect.
And the cost is pretty affordable relative to other commercial trainings and things out there. Roughly for the private sector versus academic pricing, what are folks thinking about?
So for anyone who's affiliated with the University of California, either as a student or employee, the cost is $500 for 3 days of training. And for everyone else, it's $900.
Yeah, so $300 a day. You get full day trainings by PhDs and professionals in the field, all about drone data. Pretty good deal. Drone Camp 2018. Thanks, Andy.
All right, thank you. Hope to come to Drone Camp.